Oh, and the date's wrong. What's the date today? Oh no, the date's right. Okay. Today is Monday, January 27th, 2020. This is the Kubernetes CSI meeting. So the first thing on the agenda is our feature enhancement status. Feature freeze is tomorrow, which means that we need all the keps merged and in implementable state, and the enhancement issues being tracked by the release team. So let's go down our list. First up is raw block.
Oh, yeah, I just created a cap update today, a very small one, just shifting stuff to 118.
Okay, it looks like also the enhancement is not being tracked yet, although no one from the release team thumbs up that, but okay. I guess maybe they might be waiting for the keps to merge or something, but we can ping Jeremy again to make sure this is tracked. And you have a kep out for review. Okay. All right. Next up is GA of skip attach and pod info. Hamad, are you able to give some update on this?
I think the cap is the update that I pushed is merged and caps are tracked.
All right, cool. So we're in good shape here. Okay, I'll mark this as tracked. We said we didn't need anything we don't need anything for resizing.
Actually, we did need a cap for introducing the new field that we are talking about, like in the volume the pvc.spec allocated. So it's like, and also at the minimum, we need to relax the API validation to allow the PVC size reduction actually. So the problem is that it just took like the properly fixing it by, like handling the case of node expansion where we don't know the size. It just, as we discussed on offline, it was too hard. But now I have a better looking cap, but I have not opened it yet. I have all the use cases documented, everything in detail that I shared with you and Jan, like each use case, how to look like. So, and we reduced the scope of the recovery work, by the way, to only allow, like, if you shrink the volume to recover from PVC resize failure, then the quota will not reduce by default. That's the plan we are going for, because what we have found is, like, it's very tricky to coordinate between node and controller, like two places to the size. They could return different values, and it just not worth the effort actually, and it's a bit of a edge case. So that's our current thinking, but it does require, I think, a cap, but I haven't been able to open it yet, but I could do it today. And
do you think we'll be able to make it today, or should we target this for 119?
I can open the cap, but I don't know if it will get merged in the time. We could ask for like an exception. That's this thing.
Okay.
If Saad is open for, like, I don't know, if you want to get it.
Yeah.
Okay. Okay, so this is to address the canceling the resize operation.
Yes.
Okay. All right. Okay, next up is snapshots. Since we're remaining in beta, we don't need any cap updates for this. Is that right?
We don't need any cap, but there's an issue whether it's ongoing.
Okay, like a bug.
Not bug. It's basically the library thing.
The library thing.
Mm-hmm. It basically, excuse me, somebody updated it to use 2.0, and now the API is not portable. We need to fix that, but other than that, there's no other thing.
What do you mean the API is not portable?
It's no longer go-gettable.
Oh, okay. So yeah, that's just like bug fixes type of thing.
Yeah.
Okay.
Definitely.
Are you aware of the issue that you need to append v2 to the path if you want to use go-get now?
That's right.
Okay, so you have tried that.
Yeah, that's basically the bug we're talking about, the issue we're talking about.
Yeah. No, I was just wondering because sometimes people, the repository is okay, but the go-get command is quite slightly wrong by not including the version in the path of what you are getting. And the error reporting that case is very poor from the go-get command.
You're absolutely right about that as well. We need to update the script as well so that all the generated files comply with that.
Okay, sounds good. I don't think those can be tracked as bug fixes. I don't think we need to. It doesn't change the design or anything like that. All right. Next up is volume health. Is Xing on the line? Oh, I think Xing's
not
not
here.
Okay.
Yeah, but from what I heard last time is that she had a couple of meetings. It's likely from what I heard last time, this is likely not getting merged.
I think. Well, I just talked to her, like an hour ago. She said she talked to Jordan, and Jordan had some suggestions, so she was going to update the cap for that.
Yeah, but I guess there are other opinions as well. But I'll check with her on that.
Okay, cool. All right. Next up is Windows. I think no cap is needed here since we're still trying to get the alpha out. All right. Next up is data populators.
Yeah, so thank you, Michelle and Saad, for taking a look at this and getting Tim's attention. I think I've addressed all of the outstanding feedback, and it's just a question of whether people feel ready to pull the trigger on this for 118 or if we want to argue about it for another 3 months. The Kubernetes change itself is literally going to be like an alpha gate that removes the validation on PVC data sources, and that's it. And then, of course, all of the examples around how do you actually make it work would be delivered out of tree.
So I had some questions in there, and maybe I'm missing something, but it seems to me there's a number of things missing in the PR that you have.
John, yeah, you saw the Kubernetes PR. So I provided that because in the CAP, I provided a link to like a Hello World populator, and I realized that in order for someone to download or run the Hello World populator, they need a patch to Kubernetes just so it'll work. So I added that 3-line patch to be like, here's the bare minimum you need to see how population could work.
Right.
Assuming that this.
Yep. So I completely understand, because it's the exact same thing I did last year with the populator. I have a populator and I have the Kubernetes patch. But the thing that in your cap, I made a note, if you could touch in a little bit on the namespace piece, and then the other thing is, I'm not quite sure. It looks like you're just setting a. Well, never mind. That's what you talked about in the whip. So never mind. Just read my comments, see if there's anything in there that makes sense. If I'm an idiot, just say so and I'll go away.
The only comment I see from you is the one on my Kubernetes PR, which is just a throwaway thing to help illustrate the CAP. Assuming
just added a bunch of comments to your CAP.
Oh, okay. I haven't seen that email yet, so I'll read your stuff.
Cool.
So to Saad and Michelle, do you think there's any chance of actually moving this through in 118 based on?
Yeah, I think it looks good. So based on the review that we did with Tim, I think the only feedback was before we move it to beta, we want to make sure that we've actually thought through the designs of how the populators are going to look and get that approved. But for alpha, this seems fine.
Okay, so we could maybe merge the KEP today or tomorrow, and then get an alpha version of it into 118, and then start fleshing it out.
Right. So yeah, I can help get that merged.
Awesome. Okay. So if anyone else has any other feedback, I'll try to do one last revision when I read through what John wrote, and try to get everyone's questions answered. But yeah, time is tight.
Yep, we'll get it merged in time. Thanks.
Thank you.
All right. Thank you very much. Next up, we have capacity tracking.
Yeah, thanks for your review, Michelle. I think you actually found one glaring logical mistake that I had in it with the automatic discovery of node topologies or storage topologies. But overall, the design itself of the API isn't affected by that. It's still a useful feature, in my opinion, in particular for node local storage, and that's where it's hurting most today, because that's where you are more likely to end up with unschedulable pods. There has been this feedback from Tim about doing something else like a reservation system. But as I said in a comment today, that you might not have had a chance to read yet, I think that this cap actually is a path towards such a system. It's a first stepping stone for a scheduler to make a better decision. And then if we combine it with something that perhaps tentatively creates volumes using the existing APIs and ensure that we can roll back, then we do have reservation. It's basically do a volume, keep it ready until the pod actually runs, and then you can run it with certainty. I think it's a good first step, and I think I also talked with Christian Diekmann and Xing about it. We all see that as a good thing to collaborate on, and that would mean that we should try to get it into Kubernetes with an alpha gate, of course, with a clear mandate that we need to reevaluate how well it works, whether it covers the necessary use cases before even considering to take it to beta. But I'd still like to get it in just so that we have some focus on this whole thing. Because otherwise, if we keep it out of stream, I'm just concerned that it will stagnate and people won't even look at the code if I write something.
Yeah, so I think that's the tricky bit. So first of all, I think Tim's feedback was this is a very useful feature. This is something that we should be trying to solve, but also that this is a very complicated set of code that we are trying to add to Kubernetes. And whenever we're trying to add something to Kubernetes, especially the scheduler, the bar is very high, and the default answer, he says, is no. And so he says you have to give me very, very strong justification that this makes sense. It's going to be generic enough in the future that it would apply to multiple different storage systems. It's going to be maintainable. It's going to be extensible. So it's a little bit of a chicken and egg problem of like, yeah, if we don't have an alpha, it's hard to kind of prove that. And he does have some legitimate concerns about the current approach. So I think he's looking at it from a data model perspective, where he's thinking about what is the end goal of what we're trying to achieve. The end goal is we want to give the scheduler enough of a signal that it can make smart decisions based on the capacity of the storage system when it is asking for a volume for a workload to be provisioned. And the proposal as it stands today is asking the storage system to provide some basic input about that capacity, and then letting the scheduler or some component within Kubernetes then do calculations on top of that to try and figure out the right placement.
No calculations. That's actually what's not in the cap. So the cap itself just provides ideally the maximum volume size, and all that it tells Kubernetes is you can take a volume size and compare against that.
Right.
It doesn't ask Kubernetes to do additional calculations, because those calculations actually could go wrong and could be completely off the mark depending on how the storage system works. So the cap is trying to keep it simple and just gives it some information about, no, this volume here is not going to work on this node that you're currently looking at.
Right, you're absolutely right. But even with this basic approach, even without any additional calculations, even with just here's the maximum volume size, I think the concern was as soon as the scheduler makes a operation, operates on, it makes a call to say, go ahead and provision, immediately the information is going to be out of date. And that loss of kind of synchronization between the ground truth and what the scheduler is thinking is a major concern. I think your argument for this before was that, well, strictly speaking, there are cases where it will operate better than it does today, and when it fails, it will operate just as bad as it does today. And that's an argument that we posed to Tim as well, and his kind of counter argument was given the complexity of what we're asking to add, this doesn't really meet the bar. If we really want to do this, we should do it in the right way. And so his argument is that the right way of doing this would mean that we would need to surface a lot more information from the storage system into the scheduler, and make the scheduler a lot more complicated, which smells like a fishy approach. And the other alternative to explore, which he is initially leaning towards, is a reservation system.
Yeah, but my point is, with that information, we can build a reservation system.
Just a quick thing. I just want to add is that the scheduler is extensible. So can we just create an extension and keep all that separate?
Well, how do you install it then? If it is a per CSI extension, that's kind of what Topo LVM is trying. And the author just pointed out in that particular cap here that it's a horrible experience for someone who actually tries to install the CSI driver and the scheduler extender.
Well, just to let you know, we have in Portworx, we have been extending the scheduler for a long time. It's installed when the CSI driver and all that stuff is installed, and it schedules pods to the systems where the volumes is located. It works quite well. I'm just trying to come up with another model. If you want, we could create a CSI extension that provides this, and then let the drivers, installers with the sidecars and everything install this extension too, and then you could be separate.
But that means we're never going to fix the problem in Kubernetes. We are leaving it entirely to each and every CSI driver developer to do something specific for Kubernetes that works for his CSI driver.
So I think that's maybe one thing that we potentially may want to explore, because at least from our discussions that we've had, there's so many different use cases, right? Every CSI driver might have different factors to capacity in different ways, and it might actually be kind of difficult to encapsulate in a single API. It might be an approach to consider if we can't find a generic API to represent all the different use cases that we want to support.
But I wouldn't block out trying to come up with a standard API. I think the reservation-based approach may make sense because it does leave the bulk of the complexity to the storage system. And I wanted to talk through, Patrick, your kind of thoughts on what you said, that if we go with the current proposal, the reservation system would be a natural extension of that. And I don't quite see that, so I wanted to talk through that.
Yeah, okay. So the idea was that assuming that we only have late binding volumes. Let's ignore ephemeral inline volumes for a second, because I have another proposal how to solve that more elegantly. So suppose we have volumes with late binding, and they are all going to be created for a certain pod that now needs to be scheduled.
Mm-hmm.
So in the current situation, we kick off the provisioning of those volumes. And when looking at this whole code, I noticed that we currently don't handle failure well. One comment from Michelle was that if provisioning one of those volume fails, we should retry, or if a scheduler presumably should retry. But when I look at the code, I don't think it does that, not for CSI.
Oh, then that's a bug that should be fixed.
Yeah, we could fix that. That's the whole point. We need to look at those failure scenarios and figure out whether it actually does what it is supposed to do, how it actually detects that, for example, in this particular case, it's not just a bug. Consider an immediate volume with late binding is supposed to be created on a certain node. The CSI driver currently doesn't have enough capacity of where the Kubernetes wants the volume. The right response, the right error code would be to return not enough resources. And that is not a final error. So the external provisioner will not and should not give up on that volume unless it explicitly knows that this is for late binding. So we have to add a special case here that if a late volume binding doesn't work because of not enough space, give up on that node and hand it back to the scheduler. And that is the other part that's just plain missing, I think, in the external provisioner. Looking at the internal provisioner, I found that it unsets this selected node annotation. But the external provisioner doesn't do that. So I think that was the original design, that a provisioner tries to create the volume. If it can't, it gives up and returns, basically unsets the state of the PVC back such the next time that the scheduler looks at it, it sees that it needs to find another node. But then, even if we do that, we still have that problem that to the scheduler, nothing has changed. It might make the same bad scheduling decision. And that's where my cap comes in, because even if we make the wrong decision once, the next time that all of us that goes down to the CSI driver, by that time, the information in the API server should have been updated such that the scheduler now has a better chance to pick a different node.
Got it.
And the other part about reservation, that the other idea here is the new idea that what I just described is just basic design that just hasn't been completely implemented or is buggy or whatever we want to call it. Mm-hmm. My new idea is that we mark that even suppose creation of a volume succeeds, we mark that volume as temporary or not ready for use until that pod actually starts to run. And then if that pod has one volume successfully created, but some second volume fails, we can look at the other volume that it needs, see that it has this flag that it was just temporarily created, and undo that, delete that volume again, and then try again with some completely different node. And
so that makes sense. I think what you're saying is there's kind of two parts to this, and correct me if I'm wrong, there's two parts to this. One is making sure that the parts of the Kubernetes code that today are responsible for late binding provisioning handle failure correctly, and today they do not.
Yep.
And the second part of it is making sure that when that failure is detected, what they do correctly. And that's where it sounds like we have a little bit of a fork in the road. One approach is what is proposed in the current cap, which is, we use a new CRD with storage pools with some capacity information, and the scheduler tries to make an intelligent decision based off of that. And a second approach would be reservations. So I think I would be okay moving forward in this quarter to start implementing the first part of this, which is let's just have the scheduler or the provisioning code at least retry. It could be a dumb retry mechanism, but at the very least we start fixing that. And
I would consider that a bug fix. It's not really like a new design, because
fine, as long as we can start, continue making progress on this problem. And then we can consider the figuring out exactly how we're going to make the scheduler intelligent enough to make the right decision on retry as we move forward. So instead of trying to get the KEP in the next 1 or 2 days, let's take the rest of this quarter to hammer through what all the options are, agree on something, and then get it to implementable by the end of the quarter. And that way in Q2 we can begin implementing an alpha proposal. Would that be okay with you, Patrick?
I think it just pushes out the whole solution by another quarter, so I'm not entirely happy.
It's not ideal.
It also blocks the work that I think Christian wanted to do with his API. I'm not sure why. He might pick up a branch of Kubernetes if that's okay for him. So yeah, it kind of can work. I'm not happy.
Yeah, no, I completely understand.
I also need to consider whether I now actually can still wait yet another quarter for this to land in Kubernetes eventually, because this is a pressing problem for PMM CSI. So my choice at this point has been try to get something in that at least improves the situation to keep potential customers in a somewhat acceptable state, even if it depends on an alpha feature. But now it looks like I'll first need to do what Louis talked about, do a custom scheduler extender, get that working, and that's probably what I then will work on this quarter instead of some Kubernetes enhancement or this cap. But yeah, that might work.
Okay. Yeah, and I know this sucks. I think I appreciate all the work that you've put in this, and especially trying to find a common solution that works for everyone. I think it's the right approach. It's something that we should continue to push on and get towards. I don't like having the bad user experience of like every storage vendor going out and trying to create a custom scheduler extension. If we can do this in a standard way, I think that would be the best approach.
Okay.
All right. Thank you, everyone.
Which actually gets us to the second cap, because I split out one part about inline ephemeral volumes. The size of an inline ephemeral volume is currently unspecified, or it's basically vendor specific. So for the storage capacity tracking, that is a problem, because if you look at ephemeral inline volumes from a scheduler, you don't know whether it has any size at all or any kind of storage that needs to be considered. So the proposal was to introduce an FS size field similar to what we have for PVC. But if we don't do the storage capacity tracking, I think the motivation for that cap is also lower. And in addition, Louis asked about whether we should standardize the current approach for ephemeral volumes at the CSI spec level. Because let's face it, the current ephemeral inline volumes in Kubernetes are a hack, but that is reusing the CSI spec in a way that was never formally defined, and it just happens to work within the limitations of that API. But if a CSI driver wants to support ephemeral inline volumes, they still need to rewrite it, and they still actually need to do quite a bit of additional work, and we've gone through that with PMM CSI. Topo LVM is currently working on it. As soon as you want to map that to actually creating volumes like you do for PVC, it's actually less suitable for a CSI driver developer.
So I think the main challenge is that for ephemeral volumes, a lot of the use cases that are being considered for ephemeral volumes is not necessarily the general block storage use case. It's for things like preloading, special data or secrets or configs and those kinds of things.
That might have been the original motivation, but I think now that I've looked at ephemeral inline volumes, I actually see an additional usage for it, and I think that's what both Topo LVM and PMM CSI are implementing, and that is local throwaway storage that applications can use on a node because they have they just need to dump lots of local data and process it perhaps while it's on disk instead of using RAM because it doesn't fit into RAM. And it also needs to be faster than a network attached storage device.
It's like an empty dir where you get to control the backing store.
Yeah, but for MTD, it doesn't handle things like obtain DC PMEM. That's PMEM CSI. It's less flexible than a bunch of additional disks. I think that's what Topo LVM is dealing with.
So sorry, I didn't understand what mtdir doesn't do.
It's limited to the one directory that Kubernetes knows about. So you can't tell it to get some storage through that third-party CSI driver, even if you want to. The reason why you might want to do that with PMEM CSI, for example, is because it gives you almost DRAM-like performance.
Oh, okay. So the concern is that mtdir might be slow, and you'd like to be able to say, I want a fast mtdir.
Yeah.
Or you don't want to use the resources of the host.
Okay.
mtdir does have a medium field today, but that medium field is basically limited to the boot disk or a RAM disk, and that's it.
Just bringing up how I started looking into this. One of our customers wants to do lots of analysis I/O, and they wanted to use Portworx for ephemeral. They wanted to attach it to each pod, do some work because they have to do lots of work. They didn't want to use the Docker root container. They wanted to just have a lot of work, and then each pod, when it gets created, the volume gets attached, and each pod, when the pod gets moved, the volume gets destroyed, just like a Docker volume, right? So all that management is what they were looking for, and that's one, I'm bringing it up is like that's not part. This is why I brought up everything I said on the Slack, but I feel this is I don't know if this use case is what you guys thought about. Is that
the use case makes perfect sense? I think the next question is around whether this should remain kind of a Kubernetes only extension to CSI, or should we push it into CSI?
I think just one thing. Sorry to Patrick. I think that there's a couple of issues right now. The way I know it's a hack, so I'm not saying anything against it. I'm just saying that the way it works right now is that the kubelet, it's sending a command to node attach, and we create a volume then. So it's very non-CSI like, right? There's a flow how volumes need to be created and such. So I'm just wondering, like, if we want to do this, should we create an ephemeral volume manager in Kubernetes? If CSI wants.
That was my proposal on Slack actually.
Excellent.
Let's stop doing a special case at the CSI level for ephemeral inline volumes. Let's handle it entirely in Kubernetes.
Yeah.
And my proposal on Slack was, can't we just create a PVC automatically based on an inline spec? So it's still an inline volume. You can just put something into your pod spec that says, I want a volume, but create it like a PVC with all of the fields like size, which storage class to use, which is the other thing that we currently have for ephemeral volume storage classes. And instead of doing something special at the kubelet level, the scheduler can look at this pod, see that there is one volume that is supposed to be for this pod, and it creates a PVC with late binding semantics for that pod. And then the normal PVC provisioning with late binding for that pod can take over. We can do the normal create volume at the CSI level for it. We can pick a node. All of the things that currently don't work well for ephemeral volumes would be covered by our future enhancements for PVCs. And then if we add an ownership of that PVC to the pod that triggered its creation, it also will get deleted automatically when the pod gets removed. That covers the ephemeral part.
That sounds awesome.
So when we talk about auto creating a PVC, that starts causing me angst because PVCs are user-facing objects, and anytime you have anything that the user can access, and then you automatically create it on their behalf, we should probably avoid that. So I want to take a step back and say, let's think about what it is that we're trying to solve. So initially, ephemeral volumes were trying to solve the let us inject some data into a pod use case. That made sense, and the current implementation handles that. The second use case that was added was something along the lines of empty dir with a special backing device that is not the root disk or RAM disk. That use case also makes sense. I argue that you can implement that second use case with the existing mechanism today, but I think there are some areas of friction that can be improved. And it sounds like from what Patrick and Luis are saying, those areas of friction can be improved if we push that logic down to CSI. I don't understand why we would need to create a new PVC object. Is that where the areas of friction are?
Let me reword what I'm saying, because I think it's I'm saying that the way the CSI spec today is, right, it doesn't allow for creation of volumes at node attach. What I'm saying is that if you want some type of...
What do you mean by that?
The CSI spec has a control flow where it says volume creation is done at the controller service, right, through create volume.
Right.
And I don't know if you've seen the code from host path, but what it does is that when it does a node attach and it says there's no volume ID, or volume ID doesn't exist, it creates it.
Yeah. So I mean it's an extension on top of CSI, right? It's what we've said with ephemeral volumes is it is an extension on top of CSI where a driver voluntarily opts into this additional non-standard CSI behavior. It advertises as such to Kubernetes.
Okay.
And then, Kubernetes understands how to interact with it.
So here's the situation. If we start, that's a contract that we're creating.
Yes.
Right. So that contract is like this is what I put in the Slack. It's an addendum to the CSI spec.
Correct. It's an extension.
So we need to be very clear that there's no such... If you go to container storage CSI/spec, you see a specification.
Yes.
We don't have such specification for Kubernetes. If we want to, this is also what I put down, is like, look, if we want to do Kubernetes ++ on CSI, I'm not saying no. I'm saying we need to be as clear as it is on CSI. And not only that, but we need to be, as a CSI driver, you need to be told, it's like, hey, you are now being installed in Kubernetes, right? And so you should enable Kubernetes additions, addendums, and publish them, propose them, like the interaction with the identity server. You see what I'm saying?
No, I don't follow. As far as I understand, Kubernetes has an extension on top of CSI for ephemeral volumes. I don't see that alone as problematic, but it sounds like you do, and I want to understand that.
Yes, as a CSI driver, I have customers coming in and saying, do you support this? And I'm looking at this and I'm saying, this is not part of the CSI spec, right? That alone is an issue.
So what is my question?
Huh?
So what?
So what?
Why does it matter to you whether it's part of the CSI spec or a Kubernetes extension?
It is a feature that we're missing that we didn't think we were missing because we are doing everything according to the CSI specification.
So is the problem that as a vendor, you are only looking at the CSI spec to understand what you should be adding and not necessarily Kubernetes extensions?
But that's the part. There's no such page or a spec that defines Kubernetes extensions.
I mean, there is on the Kubernetes-CSI documentation section. There's a whole page on this. The features that are listed there are,
First of all, I don't really agree that we have an extension, because that would mean that Mesos or Nomad or Docker can start creating extensions. And
absolutely they can.
Okay, so
right, so CSI as a spec dictates a certain set of core functionality, right? nothing prevents the CO from then building on top of that and saying, hey, in addition to this, here is additional functionality that we offer.
That's new to me because, as you know, I've been part of it, and all the time it was always we were creating a CSI driver system to enable a driver to be installed anywhere. But now we're missing features.
So the goal here is that if there is a standard set of functionality that makes sense across all COs, absolutely, let's get it into the common spec and make it work everywhere. But
Then,
if there is a set of functionality that doesn't make sense everywhere, like ephemeral volumes, data injection, that was a very Kubernetes specific use case. It makes sense for the CO to kind of add that as an extension on its own. If we can push it down into CSI and get the other COs to agree that, you know, the use case makes sense from them, wonderful, let's do that. And if that's kind of, you know, if this is something that you would like to pursue and drive, absolutely, I'd support it. But what I don't want us to do is limit Kubernetes to say, oh, we don't get to add functionality to Kubernetes unless it is surfaced in CSI first.
okay, then I understand that, yes. Then what I would ask is that the documentation is much more clear. Right now, if you look at the Kubernetes doc page, it's not very clear on a change from the CSI spec that was required. I would say that, you know, like we should have a Kubernetes.csi/spec, right? Just like there's a container storage interface/spec. And in that, only talk about the expectations of the contract with Kubernetes.
I think
not
that's
the sidecars.
Feedback. So maybe what we can do is on the Kubernetes CSI documentation page, for the features that are Kubernetes specific, we put some sort of note on there to say this is a Kubernetes extension to CSI, and the requirements for it are, you know, such and such.
Yeah, but the second thing too is that on this specific call, how is it that a creation of a volume is done at the node?
The wording of the language of CSI does not prevent that. All it says is that, you know, provide me a identifier at node publish time. And so, for example, you could have a pre-provision volume that was provisioned ahead of time. No create volume was ever called on it. And CSI allows for that, right? The spec is loose enough that it doesn't really dictate that. And what it ends up being is a additional contract on top of the basic spec that Kubernetes adds. So Kubernetes says, hey, if you are a driver that wants to have this additional functionality, let us know, and we know how to interact with you on top of that. Nothing in the basic spec is really violated. It's just an extension on top of what is already offered by the core.
See, I disagree, because in the node API call for attachment, it says right there in the error, if the volume handle does not exist, return error, right, in the spec.
Right, but this is an additional contract on top of the CSI spec where we say, hey, if you want to basically provision a volume at this time, you are allowed to do that.
This is what.
So you as a driver are opting into that behavior. Now, I agree. If we want to push this down into the CSI spec, let's, you know, go for it. Absolutely. If you want to drive that effort, let's do it. But
I only want to drive that effort if we're all in agreement with it, because driving things into CSI, we know that things take years.
Exactly. And that's my concern, is that, you know, I don't want us to handcuff Kubernetes to say, okay, we're not going to be able to add functionality to Kubernetes until we get all the COs to absolutely commit to it. And it may not make sense for all COs to have the same set of functionality. So
I don't mind, but
only
changing behavior of the function call is really hard.
I would have done it with a separate gRPC interface. Not reuse the existing one from CSI, but introduce your own one, because that's what you're basically doing. Publish that as a spec, create the necessary language bindings. It's more work, and in the end, the call will be exactly the same, but it will be on a Kubernetes interface that a CSI driver may or may not implement if it wants to.
I think
And
that's awesome.
that ambiguity that we are now discussing would have been gone. But I think I think I asked about that at some point, why it wasn't done, and I'm not sure whether there ever was a clear answer. It might have just been because, well, we have to maintain our own spec here and do all the necessary code generation. It just would have been more work and for a little bit benefit, but it would have been clearer.
Yeah, I think that's exactly the problem. It's like it's a cost benefit analysis at the end of the day, right? Like if we really think that this is something that can be codified in a nice clean spec, why not just push it into CSI?
Here's my suggestion. I feel that this is not just the first, this is just first of many enhancements that we may do in the future, right? I feel that if this is the way we're going, I don't mind that we have an addendum. Let's just like Patrick said, let's have a very clear service for Kubernetes, right? And in that service, we do what we want, right? But it's an extension, and it's a service that on the same gRPC port that you can listen to or not, right? And then we can do things like this. You can create ephemeral volume, right? Delete the ephemeral volume and things like that, right?
Yeah, I think that's fine. So if somebody wants to drive that effort, I think that would be, I'd be open to that. I think that effort would be better spent trying to push it back into the spec, honestly.
Again, it's I'm not saying that is an effort. We could do both.
We've got like people on this call who are all very, very busy.
No, exactly. What I'm trying to say is that this is just the beginning of probably enhancements as we come forward.
No, I completely agree. Like this is, and thank you for kind of surfacing this. I think it's probably something we should have discussed before we started the project on ephemeral inline volumes. But I think it was more of a, it is an important Kubernetes feature. Let's do what we have to do to get it in. And, you know, it often comes down to the path of least resistance. I understand where you're coming from, which is, hey, yeah, okay, we did this path of least resistance for this initial project, but moving forward, let's make sure that we're making decisions that are kind of going to make sense long-term and, you know, don't end up with fragmentation in the ecosystem, which I completely agree with.
Yeah, and that's what I'm trying to say. I mean, in the same manner, we're doing the same thing with the scheduler, right? We're not going with path of least resistance for that. There is a very stable system there.
Well, there is a path of least resistance, right? Which is fork the scheduler or create a scheduler extension.
Exactly. But there's a contract there in that extension.
Yeah. And I think we want our cake and want to eat it too, right? Let's have the path of least resistance as an initial option that is open and available to folks, but let's ultimately drive for standardization.
Yes, but that's what I'm trying to bring.
In between is where it gets weird.
That's all I'm trying to say, because as a CSI developer myself, and also being part of CSI for a while, it's just hard to get surprised by a customer saying I'm missing a feature, right? It's like I don't understand. It's like the CSI sanity passes. I don't understand what I'm missing, right? So that's what I'm trying to avoid.
That makes sense. So I think the room for improvement here in the short term, I think the easiest thing that we could do, which would not cost this group a lot of time and effort, would be to just improve the documentation and say this is a Kubernetes CSI extension that'll address this immediate use case of kind of discovery and confusion with users. And then longer term, I think I would be okay if you really strongly believe in this, like let's push it into the CSI spec, let's do that. I'm okay with that. And if you believe that having a standalone Kubernetes only CSI extension to the spec is useful, I am hesitant on that, but I'd be open to it if you want to drive it.
May I interject for one other thought here for a second? If we come back to the question of fixing the scheduler so that it can reschedule pods where currently scheduling is completely broken, for ephemeral volumes as they are done now, that just can't be done. And here's the argument why. because the scheduler makes a scheduling decision and it assigns a pod to a node, and that is permanent, to the best of my knowledge. Once a pod has a node name, it's going to be stuck on that node. No matter what we do in the node publish volume call, we can't tell the scheduler to reconsider that decision. That's a complete change in a way of the scheduler, how it works, unless I'm mistaken. But that's my current understanding. We may be able to fix PVC late binding, because there is a design, there is a way to tell the scheduler to reconsider, but not for ephemeral volumes. And I don't see a way forward how to add that.
So I think going back, Patrick, you had a original suggestion about creating PVCs and managing the life cycle of that to a pod.
Yeah.
Like, I don't know if it might be interesting to at least pursue some sort of higher level deployment object, similar to, deployments or stateful sets or jobs.
Yeah,
but one more deployment object that is sort of like an ephemeral that tailors an ephemeral use case.
That completely wouldn't work with the current stateful sets. And wherever people want to just add a volume to the existing application, it wouldn't work, because they completely have to change the deployment, who controls the deployment of a pod from, say, if you want to have a stateful set, you have to fork the stateful set and have a second version of it that also supports ephemeral volumes. That doesn't.
I've lost the context here. Can someone?
Yeah. So my original proposal was to create these PVC objects, and now Michelle said, okay, well, let's do that, but let's do it in a special controller similar to a stateful set. But then in that other controller, we basically have to implement a stateful set, a daemon set, a deployment, and we have to fork all of those and add something that knows about ephemeral volumes. And that part doesn't make sense to me, because it's basically orthogonal. How pods get created is one thing. How the volumes get created that then belong to that pod is another thing.
Mm-hmm. So what is the end goal that we want here? So we have a way to create ephemeral volumes today. I think what you're trying to say is that the problem with the mechanism that exists today is it's permanent, right?
It's permanent. It's basically happening after pod scheduling.
Okay.
That's a problem.
To account the right information.
Yeah, so I think the main difficulty I see is that we kind of have two different paths for things, right? We have a path to do things for persistent volumes, and we have a completely different path to do things for ephemeral volumes. And at least with the current proposal, we're saying, let's go ahead and continue maintaining two different paths. And, we have to solve problems in both of those paths.
Yeah.
And my suggestion is there a way we could potentially consolidate the two paths into one, so that when we solve a problem for one of the paths, we don't also have to solve it potentially in a different way for the other path.
Exactly. That also is my proposal. I just propose a different mechanism for it. But yeah, we agree on something. Coming back to Saad's concern that we are creating a user-facing component, an object here, on behalf of the user, I'd like to point out that we already do that with a PV. The external provisioner is creating a PV automatically for the user based on a PVC. So I would argue that we have precedence here. We could do the same.
It's slightly different because it's a non-namespaced object that only cluster admins can create, and application developers who use Kubernetes to deploy workloads don't manipulate PVs directly. They expect those to somehow exist. It's kind of the magic underneath. They create a PVC and then this magical thing happens. they have a certain kind of expectation of what PVCs are, how they are manipulated, how they act on them, how they're created. And so if magical PVCs start popping up in their
okay.
namespace, it gets scary because I know they're going to do something dumb like go and delete it.
Doesn't I
Yeah.
mean, maybe we don't make PVCs. Maybe we make
Well,
ephemeral objects or something.
we could create a slight variation of a PVC. The problem is that to actually reuse the exact same path as for normal PVCs, it basically has to be a PVC, because that's what the external scheduler, external provisioner is going to act on. That's also
what's going on here is that there is a missing API object here, right?
Yeah.
We have a volume attachment object, which is very clear in its intent. We never created a volume provisioning object.
Yeah.
I'm not saying we should, but
yeah, I mean, we use the PVC as that object.
Yeah, we're using PVC as that stand-in, but we're running into the edges where it clearly breaks down.
Yeah, or we just create an internal PVC.
I mean, like what Sad just said is that, if you think about it, a volume provisioning object, right? I mean, that would solve the situation with the...
I forgot how much I love these conversations.
You should join us more often.
I should.
All right. So in terms of we're running way over time. In terms of action items, where do we want to go from here?
I think first is that, and I'll take it at the action item. I'll volunteer. On the documentation page, we need a clear page on what CSI drivers need to support for extra.
I don't know if it needs to be a separate page or just a kind of notation on the existing, because there's already a set of features. And so you could add a note on top of the feature that, hey, this feature is an extension.
It's just hard as a CSI developer to know those are sidecars, and then there's like the spec at the driver, what it expects, right? There's no, like, there should be a page that's delivered that talks specifically about that, right?
Okay, put together something and then I'll help review it. I think I'm interested in figuring out what the wording here is.
Yeah, it's like, for example, if I'm passing in ephemeral volume and this is the key, something like that, you know, this is the it's a contract.
I don't
right?
want there to be more confusion from an end user perspective when they
Who's
use
the end user? No, for the driver
Kubernetes
developer.
Kubernetes end users.
Then it shouldn't be in that page at all. I don't want to put it in the doc at all. Then I'll make a new repo called spec, right?
Let's take it offline and discuss the implementation. I think there's something that needs to be done here in terms of documentation. But yeah, let's talk it through, or put out a PR and then
I'll make a new repo called spec and put it there. And we'll go from there. It doesn't have to be. It'll be in my GitHub.
Okay. All right. Get a proposal together and then we can walk through it.
All right.
Yeah, the other action item I think is fix the scheduling of late binding volumes, and I can try to have a look at that because it seems like something that could be fixed.
There may already be a PR out for it. I remember seeing one in the lib external provisioner.
Okay. But I don't see a path forward that actually fixes scheduling of ephemeral inline volumes. With the proposal that I made with PVC is the closest that I can think of that actually works. Trying to add a second path where we push back a pod off the node, I don't know. I'm not convinced that this will work. So I'm not sure how to make progress on that one.
It might be worth meeting up with some folks from SIG scheduling to sort of get their inputs on the current state of the the current state of the extenders and the new framework, and also just to ask them in general how they've solved problems similar to this in the past. And maybe that will help provide some input or inspiration for us.
Okay.
Would you like me to set up a time with some scheduling folks?
Yeah, that might help.
Okay, I will take an action item to do that then. All right. That was a very lively stand-up. Thanks everyone for staying on past our time. There are a lot of good discussions that are coming out of this. Let's see. Is there any other topics that anyone wants to talk about today?
Michelle and Saad, I just pinged you on the cloning cap for the update. If you get a chance, take a look and let me know what you think.
Will do.
And then I'll get that submitted soon today, this afternoon, or whenever. Thanks.
All right. Great. I think if that's it, then we will go ahead and end for today. Thanks, everyone.
Thanks, Michelle.
All right. Thanks, everyone.
All right, bye.
Bye.